we'll start with the problem statement. On today's test, you have a 3x3 square, and each square is either red or blue, and you can randomly choose a square that fits inside of this 3x3 square, and we can find the expected number of red squares that it contains, and if it's at least 2, then we count it as pretty. Right, so I guess that's our question. So now we want to figure out how to solve it. We begin by computing how many squares there are in total in S. Right, so S we remember is like the set of all squares that are like axis aligned and all that. So there's 9 1x1s, 4 2x2s, and 1 3x3. We can think about where the top left corner could possibly be, and then those end up being the possibilities. So we find 14 squares. And well, we remember what we want. We want the expected number of red squares inside of S to be at least 2. And well, what does this mean? This means that expected value we remember is like the total of the answer over all the possibilities over the total number of possibilities. Right, so here the total number of possibilities is 14, and so the total of the answers over all the possibilities has to be at least 28, which is 2 times 14. Right. How do we calculate the total number of red squares inside of each square? Right. Well, we can imagine it as well. Either we're counting red squares contained inside of squares in S, or we can count squares in S that are surrounding red squares. Right. So like essentially what we're doing is like we're changing what we're counting by. So here we can count in terms of red squares instead of squares in S. And so what does this mean exactly? Is well, essentially for each square, we want to see how many squares in S contain them. And then we add up that value over all of the red squares. So we can find the values for each square. Basically, the corners are each in 3 squares in S, the edges are each in 4 squares in S, and the center squares in 6 squares in S. Right? And for example, if our red squares were like the 8 outer squares that are not the center, then we take like 3 plus 4 plus 3 plus 4 plus 3 plus 4 plus 3 plus 4, and that is the total number. Right? So, and now we think back to what we want. We want to find the number of set of cells to color red such that if we total their values, it sums to at least 2. Right? So, well, what does this mean? This means, well, how do we count this? We count this by looking at 28 is like almost all of the cells, basically. 34 is like the total of all the cells. So like we can just count like which squares can we possibly exclude. Right? So we can exclude a total of at most 6. Right? And how do you count it? How do you have things that sum to 6? Either we can have just nothing, like we include everything, or we exclude a single square, or we exclude 2 corner squares, which correspond to 2 3s. Right? And so how do we count this? We count this by adding like 1 for like excluding nothing, then 9 for excluding 1 square, and 4 choose 2 for excluding 2 of the corners. And that's 1 plus 9 plus 6, which is 16 total ways to choose. And that is our final.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.